Hello everybody, we're going to talk about 6.3, the double and half angle identities this time. And there's three double angle identities that you're going to want to know. The double angle identities are the sine of 2 alpha is equal to 2 times the sine of alpha times the cosine of alpha. The cosine of 2 times an angle alpha is equal to the square of the cosine of that angle alpha minus the square of the sine of alpha. And you'll notice there's two other formulas here that we have based on the square of the cosine of alpha. We use our Pythagorean identity, we would find that one, and our 1 minus 2 sine squared alpha. All of these three actually result in exactly the same values for values of sine and cosine. For the double angle for tangent, tangent of 2 alpha is equal to 2 tangent alpha minus over 1 minus tangent squared alpha. And so that's how we would deal with it. So well, let's describe what this all actually means. Let's say we're given a problem. This is sort of a typical problem for this sort of thing. We're told that the cosine of alpha is negative 4/5 and that alpha is an angle between pi over 2 and pi. Let me see if I can draw the situation here for you. Here's an x and y axis system, so I can draw an angle in standard position. And in this particular angle in standard position, we have an angle alpha in the second quadrant whose cosine is negative 4/5. So if we were to draw this out, we would say that based on the position of the angle alpha, our cosine of negative 4/5 would be found here. Now, of course, we know what that means. That means that the sine of alpha is found by finding this third side. We're going to use this as a nice basic triangle. We've got a 3, 4, 5 triangle where 5 is the hypotenuse. And that's the angle alpha. But what we're interested in is finding the sine of 2 alpha. So you might think to yourself, let's see, 2 alpha, what could that possibly mean? Well, let's draw this in a different color. 2 alpha means take this angle right here, alpha, and double it. So if we were to make an angle that was twice as big as alpha right here, we might end up somewhere in the third or fourth quadrant. So not being really sure, I'm just going to draw sort of a representative 2 alpha right here. It means double the angle. Take whatever angle this is, double it. If it were 150 degrees, we would double that and get 300 degrees, and so on. But whatever angle it is, we're doubling that, and now we're going to find the sine, cosine, and tangent of that double angle. So that's what we're really interested in here, and this is where the formulas come in. Sine of 2 alpha is found by taking the product of 2 times the sine of the angle alpha, the original angle we start out with right here in black, times the cosine of that angle alpha. So if we make the substitutions, that means we're going to take 2 times the sine of alpha, which is 3/5, and multiply that by the cosine of alpha, which we were given as negative 4/5. So carrying out the multiplication right here, we end up with 2 times 3 times 4, so it's negative 24 over 5 times 5, that's 25. So the sine of this double angle formula right here is negative 24/25. For the cosine, we can use one of 3 formulas. Cosine of 2 times an angle is equal to either cosine squared alpha minus sine squared alpha, 2 times the square of the cosine of alpha minus 1, or 1 minus 2 sine squared alpha. Since we're given cosine of alpha, I'm going to go ahead and use that second formula. So I'm going to take 2 times the square of the cosine of alpha and subtract 1 from that value, whatever it is. In this case, that turns out to be 2 times the square of negative 4/5, and then we would subtract 1 from that result. Oh, squared right here, pardon me. So this is actually the same as saying 2 times 16/25 minus 1. Well, that's like saying 32/25. And if we're subtracting 1, it's like we're subtracting 25/25. And so our cosine for the double angle will end up being positive 7/25. And this seems to confirm that we are in the fourth quadrant for this double angle. Somewhere here in this quadrant 4, we've got a positive cosine and a negative sine. So now let's take a look at the tangent of 2 alpha. We should end up with a negative value if we've done everything else right. So let's go ahead and substitute in 2 times the tangent of alpha divided by 1 minus the square of the tangent of alpha. So making the proper substitutions in the proper places, we should be taking 2 times negative 3/4, and we should be dividing that by 1 minus the square of 3/4. Sorry, negative 3/4 quantity squared to be accurate. So that's, what do we have here? This is like saying negative 3/2, right? 3 times 2 is 6 divided by 4. That reduces to 3/2. And in the denominator, we will have 1 minus the quantity 9/16. We're working our fraction out. We're going to have negative 3/2 divided by 16/16 minus 9/16, so that's 7/16. And so we invert multiply our denominator right here. We're going to take negative of 3/2 and multiply it by 16/7. 2 goes into 16 8 times. And our result will end up being negative 24/7 for the tangent of that function. So that's what we were looking for right here. This is one use of these double angle formulas.